Okay, let's set a scene. Imagine you're designing the AV for, I don't know, a new airport terminal or maybe a huge medical campus.
Yeah.
You got your main server room locked down in some basement, but you need to get perfect uncompressed 4K video to a screen 3 buildings away.
And that's where you hit the wall, the copper wall.
Exactly. You run a normal HDMI cable and what, 20 feet later, the signal just dies. Physics wins.
It always does.
So today we're diving into a piece of hardware that claims to, well, cheat physics. We're looking at the NTI ST-IPFO4K18GB-R-LC.
That is a mouthful. It's an 18 gigabit per second HDMI extender over IP. We're specifically looking at the receiver unit.
Yeah, and our mission for this deep dive is to figure out how this thing moves massive uncompressed video over these, frankly, ridiculous distances without turning it all into a pixelated mess.
To really get the solution, you have to appreciate the problem. You know, 4K at 60 hertz, it isn't just more data, it is a fire hose.
18 gigabits per second.
Exactly. Copper just has too much resistance. That's why that 20-foot limit is so real.
So NTI's solution is to swap the copper for glass.
Yeah.
Fiber optics.
Right. And this is where the specs start to get a little bit nuts. If you use single-mode fiber, the 9-micron stuff for long-haul telecom, you can push that signal up to 24.8 miles.
Wait, 24.8?
Yeah.
Nearly 25 miles. That's not a campus anymore. That's the next town over.
It is.
But hold on. My hesitation there is latency. Usually when you send video that far, you get lag. You move a mouse and, a second later the cursor moves.
Well, that's the classic trade-off with compression, right? But this unit claims 0 latency. And that's because it's not squishing the signal down. It's using the full 18 gigabit pipe. It keeps a video at 4.4.4 color.
Okay, so for those of us who aren't video engineers, why does 4.4.4 matter so much?
It means every single pixel gets its own full color information. Most streaming video, like on Netflix or YouTube, throws away about half the colored data to save bandwidth.
Chroma subsampling.
Yeah. And for a movie, your eye doesn't really notice. But if you're looking at an MRI or a spreadsheet with tiny red text on a black background, you need every bit of that data. That's 4.4.4.
Got it. So we have the quality, we have the distance. But the name says over IP. Now, this is where I want to push back a bit. Does that mean I could just plug this into my office network and it works?
No, absolutely not.
Because 18 gigs would just destroy the email server.
It would bring the entire network to its knees. And you really nailed the challenge for installers here.
It turns an AV project into a full-blown IT project.
Precisely. You can, do a simple point-to-point connection, one transmitter, one receiver, one fiber cable. That's easy.
Okay.
But if you want to go point-to-many, like for those airport flight screens, you need a managed 10G SFP network switch. And, critically, it has to support jumbo frames.
Jumbo frames, what are those?
So think of a standard network packet as a regular letter envelope. It's fine for an email, but 4K video is like trying to mail a car.
You can't just chop it into a million envelopes.
Right. The overhead would kill you. A jumbo frame is like a shipping container. It lets the network move huge chunks of data all at once, much more efficiently.
That makes perfect sense. So you need a dedicated high-speed lane for this video traffic.
A dedicated lane. And the switch needs IGMP support. It's like a traffic cop that makes sure that massive video stream only goes to the ports that actually asked for it.
So it isn't flooding the whole system.
Exactly.
So if you've got the right infrastructure, the fiber, the managed switches, you could scale this up to, 255 receivers?
That's right. You can create a many-to-many matrix using VLANs. You could have a control room 20 miles away, seamlessly switching between hundreds of different sources.
And you still have control, right? It extends RS-232 and IR.
Full control. It's like the server is right under your desk.
That's impressive. Okay, let's talk practicals. This is enterprise-grade gear. What's the damage to the budget?
The receiver unit is around $485, which, when you think about it, is actually pretty competitive. It comes with a 2-year warranty, and it's replacing these old proprietary matrix switchers that used to cost a fortune.
So it's really a bridge device, isn't it?
Yeah.
It's taking the HDMI standard, which we think of as local, and forcing it to play by the rules of long-distance telecommunications.
That's the perfect way to frame it. It completely decouples the source from the display.
Which, that brings you to a final thought. We've always assumed that high-security work or, high-end video production has to happen on site. You have to be in the room.
Physical proximity was a requirement.
But if tech like this can send an uncompressed, zero-latency signal, 25 miles, are we getting to a point where the secure facility is just a server in a bunker somewhere and the actual control room could be anywhere?
When distance no longer equals latency, yeah. The whole geography of secure work just becomes theoretical.
Something to mull over. Thanks for joining us on this deep dive. Stay curious.